Like most other functional groups, there are two distinctly different ways to name carboxylic acids. They're the names that we call common names that don't tell you anything specific about the structure. You simply have to memorize the name and structure together. And then there's the IUPAC systematic nomenclature, where we follow a set of rules, and everybody will draw the same structure based on the name itself. Let's look at the common names first. There are a few that you really should memorize. Formic acid is the smallest carboxylic acid. It's important chemically and biologically. Acetic acid, 1 carbon bigger, is important to us in the kitchen. It's the component of vinegar that gives the sting to it. It's also very important biologically because it's a building block for many compounds. The 4-carbon acid pops up quite a bit, butyric acid, so it's worth learning. And you may have already seen benzoic acid. It pops up chemically and biologically, and it's essential that you know its name and structure. Beyond that, there are a couple of structures that I put on here because they play important biological roles. Lactic acid accounts for the soreness in muscles when muscles are overworked. And pyruvic acid is an acid that plays important roles in metabolism. Beyond these structures, there are a few dicarboxylic acid structures that might be worth knowing as well. Oxalic acid is the smallest dicarboxylic acid. Malonic acid is the next biggest one. It plays an important role in synthetic organic chemistry and plays important roles in metabolism as well. The 4-carbon diacid, succinic acid, also plays important roles chemically and pops up biologically. So there we have sort of a minimum set of structures whose common names it would be good to know. Let's turn to the systematic naming of carboxylic acids using the IUPAC rules. Following 8 steps in a systematic order, it's possible to name most any organic structure. While you may have seen these steps before, let me briefly summarize them. The very first thing you need to do is identify the highest priority functional group, and following that you need to find the chain that is the longest chain that contains that functional group. You'll start by assigning the alkane name that's associated with the longest chain, and then change the ending to indicate the highest priority functional group. Beyond that, you need to identify and name all of the substituents that are attached to the chain and place them in alphabetical order in front of the root name that you've already constructed. Then you'll number the chain, beginning at the end that's closest to the highest priority functional group. And using those numbers, you'll assign the numbers of each substituent and place those in front of the substituent names. And finally, if there are any stereochemical designations, like R and S or E and Z, they need to be put out in front of the name itself in parentheses. Let me apply these steps to some carboxylic acids as examples for naming using the IUPAC system. In this example, the highest priority functional group is the carboxylic acid, and a 4-carbon chain contains that functional group in the alkene. And that's the longest chain that contains both of those functional groups. So we'll call it a butane. Because it's a carboxylic acid, we'll change the E on the end to OIC and add the word acid. And we've got to describe the other functional group, so we'll change the A to E to indicate the alkene. There are 2 substituents, a methyl group and an ethyl group, and we'll put them in alphabetical order. We need to number the chain, starting with the carboxylic acid, which is always carbon 1, and use those numbers to designate where the substituents and the alkene are. We have 3-ethyl, 2-methyl, 3-buteneoic acid, and there's our name. Notice that we have a chiral center in the molecule, and if the stereochemistry is specified, we'll need to specify the stereochemistry as well. Take a look. I've written the same compound, but now I've designated the stereochemistry. And using the Kahn-Ingold-Prelog rules, we'll designate the priority of each substituent attached to the stereogenic center, this carbon atom. This is the highest priority. The second priority, the methyl group would become 3rd, and that hydrogen is the 4th priority. Now remember, we go from 1 to 2 to 3, and if the 4th priority group is away from us, clockwise tells us that it's R. But when the 4th priority group is facing us, we get the wrong assignment. And this stereochemistry is actually S. So the full name of this compound is just like above, but we'll put the S stereochemistry in front in parentheses. Let's look at another structure. The longest chain that contains the highest priority functional group is 5 carbons. So the root name is pentane, and we'll have to change the E to indicate that there's a carboxylic acid by writing OIC, acid. Notice that there's a second functional group, a ketone. We're going to name that like we name substituents and call it the oxo group. Phenylpentanoic acid. We still need to use numbers to show where these are. Always start with carboxylic acid as 1. So this is 4-oxo, 3-phenylpentanoic acid. There's a stereogenic center, but it doesn't show the stereochemistry, so we can't name the stereochemistry. Aromatic carboxylic acids are named as benzoic acids. We'll need to write the names of substituents that are attached to the ring, putting them in alphabetical order. Carbon number 1 is always the carbon that has the carboxylic acid attached to it in an aromatic ring. So this benzoic acid has carbon 1 here. We'll go around the ring in the direction that gets us to a substituent most quickly, which means we have a 5-bromo, 2-chloro, benzoic acid. Dicarboxylic acids are named by first writing the root name of the longest chain. We have 5 carbons here, so this is pentane. With monocarboxylic acid, we would drop the E, but with dicarboxylic acids, we'll leave the E and indicate there's 2 carboxylic acid groups by saying dioic acid. And if this compound had a substituent, we would number the chain from the end that's closest to the substituent, put the substituent name out in front. 2-nitropentane dioic acid. It's also important to know how to name the salts of carboxylic acids. Let me give you a few examples. To name the salt of a carboxylic acid, we'll drop the acid and drop the IC. We'll add ATE to the end and put the name of the cation out in front as a separate word. So you see we dropped the IC and the acid and added the ATE. Acetic acid becomes acetate. And because this is a sodium salt, we call it sodium acetate. For butyric acid, we've done the same kind of thing. We dropped the IC and acid and added the ATE. Butyric acid becomes butyrate, and we'll name the cation associated with it. This is the ammonium ion. The next one is something that you're very familiar with, even if you don't know it. We eat lots of sodium benzoate. It's put in many foods as a preservative. Look at the labels of packaged foods in the grocery store. Sodium benzoate is a common ingredient. Again, we've made the name by dropping the IC and acid. We've added the ATE, so benzoic acid becomes benzoate. And because this is a sodium salt, we call it sodium benzoate. And one last example, using the IUPAC systematic nomenclature. We do the very same thing. 2-chloro-3-butanoic acid, by dropping the IC and the acid and adding the ATE, it becomes 2-chloro-3-butanoate. The full name is lithium 2-chloro-3-butanoate. Naming carboxylic acids and their salts is straightforward using the 8-step procedure of the IUPAC nomenclature.